Welcome to F+L Webcast. My name is Vicky Denton, and I'm your host. Our guest today is Ed Becker. Ed was past president of STLE, the Society of Tribologists and Lubrication Engineers, from 2007 to 2008. He's a fellow of STLE, which is the largest technical society dedicated to tribology and lubrication engineering. Ed holds a PhD in mechanical engineering from the University of Michigan in degrees in material science. He retired from General Motors after 30 years of service, mostly in the Powertrain division, working on a variety of GM engines and transmissions. Ed then established Friction and Wear Solutions, which provides advice and materials to solve tribological problems. Ed holds 9 U.S. patents and is a licensed professional engineer in Michigan. Welcome to F+L Webcast, Ed.
Thank you, Vicky. Good to be here.
The world is changing in front of our eyes. And 30 years working for General Motors, you have seen a lot. Take us through the biggest change that you've seen happen in today's world, at least on the automotive engine side.
Wow, that covers a lot of territory. But I will tell you that when I joined General Motors, the company had just shy of 2 million employees worldwide. Shortly after I joined, GM acquired EDS, Electronic Data Systems, and Hughes Aircraft, at which point GM had more than 2 million people worldwide, hourly and salary total. Shortly after the bankruptcy in 1999, the company was down to about 180,000 employees total worldwide. It's now back up over 200,000. But that's one of the biggest changes is just the total employment. Now, does that mean GM makes fewer vehicles than they did? No, they actually make more vehicles per year than they did when they had 2 million employees.
So
So
when
a
they had 2
huge,
million, when they had 2 million employees,
Mhm.
how many vehicles did they produce a year?
About 5 million a year. And I would have to
And
look at what the number is now that they produced in the
mhm.
last few years, but I believe it's more than that. Again,
and
that's
that's
total
because
worldwide.
and that's because the world has automated a lot of functions that used to be done manually, right?
Yes, I believe a great deal of it is automation, but also a great deal of it is um, diversifying, in the case of General Motors, diversifying their parts and components businesses. For example, that not all of those people lost their jobs. GM spun off its components in a unit called Delphi, which makes a lot of parts and accessories. They did spin off both Hughes Aircraft and EDS at some point. Those were hundreds of thousands of people who, as I say, didn't lose their jobs, but they were moved out into a different company. So part of it was GM focusing on its core business. And part of it was, as I say, moving out of the components businesses. But a great deal of it was automation, more efficient use of the facilities. And some of it was closing down less profitable divisions. You may remember companies like Pontiac, Oldsmobile, and Saturn that don't exist anymore. Uh, GM felt that it was duplicating uh, product among the different lines, so it was believed that they could consolidate production into the fewer divisions without giving up their range of product. So all of those have happened a lot in the past, 40, 45 years now since I've been involved.
On the engine side and the transmission side, and what was the biggest change?
Well, let's see. On the transmission side, what I would say is the move to more forward gears or multi-speed transmissions. When I started, the standard transmission had 3 forward speeds plus reverse. That quickly went to 4, then 5, then 6. I think it was up to about 8 when I retired, and I think I just read that the new transmission plant that GM is putting in is going to have a 12-speed automatic transmission. So what that allows you to do is it allows the engine to operate closer to its peak efficiency more of the time. So it increases fuel economy tremendously. Now, there has to come a point of diminishing return because as you add more gears, you're adding complexity, you're adding weight, you're adding control issues of how you manage the shifts among them. So I think and I could be wrong here, but I think we might have seen the peak of the number of forward gears in an automatic transmission as of now. And I would also argue that when it comes to engines, something similar has happened. When I started, the entire emphasis was on improving fuel economy. Of course, that wasn't too long after the oil shock of the 1970s. So we were doing everything, and everybody was doing everything to improve efficiency with lightweighting. In other words, substituting aluminum for iron and steel wherever possible, substituting polymers and plastics for aluminum wherever possible, downsizing the engines. We went from very large engines to much smaller engines and fewer cylinders in many cases. And improving those engines became a marketing advantage. You could say your engine was better than your competitors because it had this and that feature. But I think what's happened in the last decade or so is, and I probably should talk about electric vehicles as we get into that, there's been a big shift in emphasis in terms of meeting not just fuel economy goals, but also ecological goals. That electric vehicles, there's pretty much a consensus that's the way to go. And according to the numbers I just saw last year, 20% of vehicles sold worldwide, passenger vehicles, were electric vehicles. And that's quite a change from when I left, as I say, almost 15 years ago, where it was about 1%. So the growth has been very substantial. But I think what's happened is the engine in those gasoline and diesel cars, there's been less emphasis on improving them, less emphasis on making new engines, and less emphasis on it being something that differentiates one car from another. I kind of think of it as the internal combustion engine has gone from being a marketing tool to pretty much an appliance, where if you think about it, when you buy a refrigerator or a stove or a microwave oven or a clothes washer, you look at the features, you look at the buttons, but you look at how easy it is to operate and what it will do for you. But if you looked inside of it, you'd probably find there are only two or three manufacturing facilities worldwide that are making all of the condensers, all the magnetrons, all the electric motors that are in those things. So they've become, it's the applianceification, if you will, of the internal combustion engine. So we shall see
I
how that turns out.
I guess in a way it's also as companies like GM, and I don't think it's just GM, that basically spun off divisions to be formed as separate entities. Companies, I would say that, they call them tier one suppliers or tier two suppliers or whatever. We're basically selling the same thing to different manufacturers, right?
Yes. And it's interesting, as you mentioned, I worked for the powertrain division. Now, for a long time, the different GM divisions had their own engines, but it was sometime in the 1970s and 80s where they began to use the engines across different um, makes and models. So that's when GM Powertrain came into existence, and um, we sometimes refer to it as tier point five, if you will, meaning even though it was part of General Motors, Powertrain would sell its engines and transmissions to Buick, Pontiac, Cadillac, whoever the the car makes were. And so you were actually in competition with the other engine plants to get your engine into a Chevrolet or a Buick. And so
So,
far, they've held on to those.
so you lost differentiation.
Yes, that's true. Some of the divisions, Cadillac notably, always had the right to have an exclusive engine. For example, the one that I worked on was the North Star engine, and that was exclusive to Cadillac. But most of the other engines could be, you might find the same or essentially the same engine in an Oldsmobile or a Pontiac or something like that.
And is that because Cadillac is the top tier brand of GM?
I believe so. I believe that was the thinking.
Yeah, so we kind of make our own, how would you say it, destiny in that sense. Because as companies decided that they have to improve efficiencies and shareholder returns, they became commoditized. They started offering engines that are more commodities rather than uh, something special to the consumer. And the consumer realized that. Would you say that's an accurate statement?
Yes, but I would go further and say that unlike those of us who've been in the industry, I we get very excited about those specialized engines and their features and capabilities. But when you're selling, like I say in General Motors' case, 5 million vehicles a year, that's a much broader base of people who want reliable transportation, an engine that starts, gets them onto the freeway in a reasonable time, doesn't break down, and uses a reasonable amount of fuel. So I actually think that's the majority of the customer base. It actually was the majority of the customer base, and it's only now becoming the case where I think that differentiation is not being invested in to the same degree. You
And
know,
perhaps what electrification has done is even, how would you say it, exacerbated the commoditization, right? Now it's all about
yes,
looks.
yes, it
Well,
is. In fact, if you think about it, you don't see any of the electric vehicles advertising their motor in particular. Um, they'll talk about their range and their 0 to 60 mile per hour times in performance and other features. Like these days, of course, self-driving is something everybody's talking about. We were talking about that in the 1980s, by the way, at General Motors. When would that come about? The first adaptive cruise control and lane keeping abilities go back that far, if not further. But those are the sorts of things that are now differentiating the product.
but
And
but the evolution of electrification actually goes a long way. You were saying it started very, very
started
early on.
in the 1800s. In fact, Thomas Edison, if you look it up, had one of the early battery production facilities for electric vehicles and drove an electric vehicle himself. Henry Ford's wife, I forget her name, had a Detroit Electric vehicle that she drove. So there were some very good features about electric vehicles which persist to this day. They have fewer moving parts, so they don't break down quite as easily. If you go back to the 1900s, you remember this was before automatic transmissions. So you had to be able to drive a car with a clutch. So they were harder to drive. They were more prone to breaking down. They were noisy because you didn't have the muffling systems and the like that you have now. They smelled bad because gasoline, oil, and greases were all pretty much external. They weren't contained. If it broke down, you had to get out and crawl under to reset the chain or other things like that. So for that reason, the EVs of the early 1900s were sometimes referred to as ladies' vehicles. They were popular among women. Um, in those days, also, one of the important features of you have to realize now we talk about we want ranges of hundreds of miles or hundreds of kilometers. It was very unusual in the 1900s for anyone to drive more than 10 miles a day.
Because of the
So,
roads.
because of the roads, there were no freeways. The roads were unimproved. If you drove, it was on your own property or at most to town and back. So, a 10-mile range was perfectly fine. And if you look at the disadvantage of electric vehicles, I just mentioned one, limited range. The second is the EVs cost about 3 times or more of what a internal combustion engine car cost at that time. So they were high priced. And the third thing is you had to have a source of electricity, which again in 1900 wasn't everywhere. So you had to have a place where you could access electricity to plug the vehicle in. And even at that time, they took hours and hours to charge. So high cost, range anxiety, and long charging time were the problems in 1900. Guess what? Those are the
There's still
problems
the same
today.
problem.
Yes,
Yeah,
exactly.
that
Now we've made
that is
tremendous progress.
that is fascinating.
Mhm.
And what, oh, okay, so those were the issues then. And then what
Yes.
happened? Why did suddenly electric vehicles lost the market? back then?
If you go, if you look at the modern resurgence of electric vehicles, you can pretty much date it to the GM EV1, which I think was 1996. GM came out with a electric vehicle, fully electric vehicle. It used lead acid batteries, which is the standard technology. It had an advertised range of 100 miles, but under real world conditions, that was more like 60. And it never met its sales targets. And I'll put the word sales in quotes because GM didn't sell them, they only leased them. But the people who bought them, again, quads, bought, leased them, loved them. But it just never reached the market share for exactly the three reasons I mentioned: limited range, high cost, and limited range, high cost, and what was the third one? Oh, long charging time. The
What was the
big thing,
impetus though? What was the impetus though for GM to introduce it at that time?
well, in the United States, the government regulates our fuel economy. And one of the ways you can manage your fuel economy as a corporation is if you sell very efficient vehicles, then that helps your average. And electric vehicles at the time, and I believe still do, get some very favorable treatment for how you calculate your corporate average fuel economy, or CAFE, as it's usually um, abbreviated. So there was a tremendous financial incentive in terms of avoiding penalties for not meeting fuel economy goals. That's one reason. The other was just to test the market to see if it would sustain. And I like to point out that at the time GM was making the EV1, Toyota was making the RAV4 EV, and there was another company, Think, in Norway, Think with an exclamation point replacing the I. They all were in the market, and they all pulled out about the same time GM did because they reached the same conclusion. The investment wasn't justified for what the market looked like at that time. Again, this is 1996. The big
So
change,
if if it's a corporate average fuel economy though, you
mhm,
need to get a certain volume, right?
correct.
What
That's
what
correct.
was what was GM's target?
It's been long enough, I don't recall. I'm sure that there were accountants who worked out, how much each vehicle was worth in terms of avoiding penalties for fuel economy. And I assure you that whatever the lease price was, and I don't know what it was, accounted for what it needed to be to get a certain number of those vehicles on the road. It probably didn't reflect the actual cost of building and operating and maintaining that vehicle. Because as I say, since GM was leasing them, GM was the owner and had to maintain them. It did bring out about a number of innovations that we have in our vehicles to this day. Probably the biggest one is something called regenerative braking, where in every EV that I know of that's out there, if you step on the brake lightly, you don't actually activate the brake shoes. You activate the motor, starts to absorb energy from the wheels and put it back into the battery. So I understand the efficiency of that is somewhere around 60 to 80%. So you're turning the kinetic energy of the vehicle back into electric energy stored in the battery. That's the big strategy, one of the big strategies that increases range. And that was basically pioneered on the GM EV1. But the other big innovation is, as I say, the EV1 used standard lead acid batteries, which are very heavy for the amount of energy they carry. We are now in the era of the lithium ion battery, which is a much higher, much more dense way of storing energy, store a lot more energy in the same size package. And they continue to improve. And there are other variations of that that are coming into the market now. I understand, again, you look at the typical electric vehicle on the market today, 300 miles, or what's that? Uh, about 500 kilometers is a typical minimum range that you'll find in EVs today. Well over 400 is common. And if you look at standard gasoline powered vehicles, about 400 miles on a tank of gas is pretty standard. What's that? That's 400, 5, 6, about 650, 700 kilometers on a tank of gas is fairly typical. So at least in terms of a single charge or fill up, EVs are now comparable to the standard vehicles and how far they will go on a single charge. You still have the problem of long charging time and high initial expense, though.
Yeah, and the infrastructure because you don't have as
And
many. EV charging stations as you have gasoline stations, right?
Correct. And that becomes a societal issue. And in the United States, we've had some steps forward and some steps back on that. And I guess I'd I would like to point out that the charging structure is much more pervasive than it was even just a few years ago. But right now, we seem to be in kind of a holding pattern on that. I'm not sure how far that's or quickly that's likely to advance. That's probably one of the things holding back EV sales in the United States right now. But in a lot of the rest of the world, they don't seem to be having that problem. The growth in EVs worldwide continues to be quite substantial.
Yeah, and I think the next generation of batteries will be even more efficient than lithium-ion batteries, right?
Yes, I'm seeing indications that the next generation of batteries, one benchmark that's used is how quickly can you charge from 20% to 80%, because it's the nature of all battery systems that as you approach 100%, excuse me, as you approach 100% capacity, the charging rate drops substantially. So the quickest way to charge is up to about 80%. And so using that as a standard, a typical lithium ion battery, if you were going to charge that using 110 volt household current, what we have in the USA, it would probably take you somewhere around a day and a half. So 36 hours, that's obviously not going to work. So what we have is something called a level 2 charger, which is based on 220 volts. That will get you from the 20% to the 80% in about 4 hours, which is not bad. If you're using it during the day, you can charge overnight, no problem. And then we have what's called DC fast charging, which cuts that down again to about an hour. And I'm understanding the next generation of batteries will accomplish that same charging in something under about 20 minutes. And now we're talking something reasonable for if you want to drive a long distance, you can stop and charge your vehicle at least, as I say, if you run it down to 20%, you can get it back to 80 in 20 minutes. You can do that during a fairly standard service stop. You're not looking at, having to spend hours to wait for your vehicle to be ready again.
Now,
So
the lubricants industry, um, I would say 5, 10 years ago, were very concerned about the future demand because of electrification. But the concern doesn't seem to have panned out because actually the challenges, I would say, that electrification has brought about are actually more difficult. I mean,
yes, they are.
how would you characterize the main issues now relating to fluids
Uh,
for electric vehicles?
okay, well, let's start with the greases, and and particularly in terms of the body and the chassis, there's effectively no change. So you're still selling all your greases for wheel bearings and doors and hoods and closures and all of those other things. So that's effectively unchanged. When we get into the powertrain, of course, you no longer have engine oil. You no longer have combustion taking place, which is what really is the biggest challenge for engine oil. So you do away with that right away. Now, you still do have gears in an electric motor because electric motors, they operate most efficiently at relatively high speeds. And most electric motors, the size of what you find in a car, their peak speed is somewhere around 20,000 RPMs. But if you think of a vehicle going down the road at 60 miles an hour or 100 kilometers per hour, if you do the calculation, you find the wheels are actually turning at around 1,000 RPM. So you've got to step down the speed of the engine to match the wheels. So the vast majority of vehicles now use a single stage reduction gear, usually somewhere around between 6 to 1 or 8 to 1. So the wheels are turning at roughly 1/6 or 1/8 the speed of the motor.
So what does that
And
mean for the lubricant?
well, you need a lubricant, first of all. Those gears can't run dry. If you think of standard transmissions where you have all those gears, we always use something called transmission fluid. And so the very first step, what people tried was, well, it's a gearbox in the sense that it's a box that contains gears, this reduction gear. Let's put transmission fluid in there. But there's a major problem with that. if you think about how internal combustion engines work, when you're getting onto the road, you need to increase the speed of the engine up to sometimes several thousand RPM before you reach peak power or peak torque, where you get your best acceleration. So the nature of internal combustion is you have low power at low speed and high power at high speed. So just talking about the engine now, not the vehicle. So if you want high power, you've got to rev the engine up. Well, that means your oil pump is spraying oil everywhere. You're splashing oil all throughout of it. So when you reach that high power region, you have lots of oil, and that's a good thing. Same thing with the transmission, by the way. Problem with the EV is you get peak power at zero speed. So when you first start out with an EV, if you put peak demand on it, you have the highest load on those gears. And if they're hardly moving, you have a very hard time distributing the lubricant. So you have exactly the opposite problem. You have high power demand, high stress at low speed and lack of lubricant. So what's being done now, and I believe quite successfully, is dedicated EV gearbox, and I'll put that in quotes again, gearbox lubricants are being developed for exactly that problem. Um, and I think tremendous progress has been made in that. The other thing you have in EVs that you didn't have in the internal combustion engine is you have very high electric fields to deal with. So you have to worry about how your lubricant reacts in the presence of those electric fields. Now, you might think offhand that these fluids are pretty much good insulators, so maybe you just want an insulator. But the problem with that is in an electric system is you can accumulate charge in different components. And if your fluid is a perfect insulator, that charge will accumulate until it reaches a critical value where it will arc across a gap. And basically essentially you have a tiny bolt of lightning striking uh, inside of your enclosure, and that can lead to all sorts of other problems. Electronic discharge machining, or EDM, is something we do in the manufacturing world, which is a controlled form of electric discharge in order to remove material. Well, if you have that happening uncontrolled in your motor, you're removing material from critical components. But you also don't want the fluid to be a conductor because you don't want it carrying electricity. You don't want it to be a good conductor because then you're losing electricity through parasitic paths. So there is an ideal value for conductivity for that fluid. Not so high that it bleeds out electricity from where you want it, but not so low that it allows charge to accumulate where you don't want it. And actually, that is a very active area. What exactly is that number? How do you get it? And how do you maintain it over the life of the lubricant? Because you're not changing these gear fluids very often, if at all, in the life of an EV. So we have to look at aging as a consideration as well. So those are the two big challenges for the EV lubricant. The other thing from a fluid standpoint is when you're moving this amount of electricity very quickly, as you might remember from your circuits course, you generate a lot of heat. And the electric components that are managing all of this are using electricity and generating heat. So you still need a coolant, you still need a radiator. So we still have demand for those sorts of things. Now, they're not encountering the direct path of the electricity so much as the motor is, but you still have to be concerned about the presence of high electric and magnetic fields in the vicinity. And so optimizing the fluids for that sort of thing is another very active concern. Optimizing them for heat transfer, uh, again, another concern. So the total volume of fluid is less, but it hasn't gone away for people in the fluids industry. What really has gone away is combustion. And that's why we have to change engine oil, still every these days now. I think a typical engine oil range that the manufacturers are using is about 10,000 miles or 16,000 kilometers, which is still quite a few times over the life of a vehicle. As I say, I'm not sure what the requirements are for the fluids in EVs, but they're nowhere near that. So the amount of the fluid changes and maintenance is considerably reduced.
We have to unpack what you said because you said a lot of things.
Okay.
You make it so sound so simple, but they're not that
Hmm,
simple because,
okay.
both you and I were sitting listening to papers, technical papers being presented at STLE last month. And it seems like a lot of the work, or at least a lot of some of the papers that I've listened to, were really fundamental studies, which is interesting. We don't really exactly yet know what the perfect fluid is, do we?
That's correct. I mean, I agree with you absolutely on that. There's a lot of
Wh-
active research going on, both fundamental, as you say, and within the um, companies, the oil companies, the additive companies are working. They see this, I think, as a opportunity to differentiate their product. So not everything that they're doing is being shared publicly necessarily, but it's a very, very active area of research.
And then there's also the in between, Ed, what we call the
Mhm.
hybrid,
Mhm.
right? Different
Yes.
issues with hybrids. Can you maybe talk to us about
Yes.
hybrids and how their requirements are different from pure EVs?
Absolutely. So a hybrid uses a smaller electric motor and a smaller battery, typically um, enough to get the vehicle started and maybe to run about, 40, 50 miles just on the battery alone. But then it also has a small internal combustion engine and a gas tank or gasoline or diesel tank that when the battery becomes depleted, or if the battery isn't putting out enough power to accelerate the vehicle, say, the internal combustion engine starts up and supplements um, the battery. And if the battery becomes completely depleted, the vehicle runs on the internal combustion engine alone. It's a very nice pairing for several reasons, one of which I already mentioned. The internal combustion engine produces peak power at high speed. The electric motor produces peak power at zero speed. So an electric motor, even if it's not very big, you can launch a vehicle and get it going very quickly on just the electric motor. And then the gasoline or diesel motor can kick in and provide power at high speed. So it's a very nice pairing where you can get power in two different bands, depending on whether you're going fast or slow. The other thing that the electric motor does is it allows you, if you're supplementing the gasoline engine or diesel, you can use power from the electric motor so that you can keep the internal combustion engine motor running near its peak efficiency. So it doesn't have to necessarily run faster to keep the car going at a certain speed. It becomes much more efficient for that reason. So the mileage or the fuel economy of a hybrid is substantially more than a vehicle that runs on just an internal combustion engine. It works very well when the vehicle is being driven at different speeds, and particularly at relatively low speeds, where the electric motor is doing a bunch of the work. And then what happens, by the way, if you're driving on the highway and the internal combustion engine is turning fast, you take the extra electricity from the generator and you put that back into the battery. So you recharge the battery using an excess energy from the internal combustion engine. So it's a very nice system that gets some very good efficiencies, really reduces the amount of fuel you're using. Uh, if you're going a long distance, you can refill the tank in the same time it takes to refill an ordinary gasoline tank, 5 minutes or so. So that's very good if you're doing long distance driving. And if you mostly drive at low speeds, stop and go in cities, for example, that's where the hybrid really shines. In fact, you'll find if you're used to fuel economy numbers on a standard vehicle, we always talk in the United States about highway and city mileage, and typically the highway mileage is higher than the city mileage. It might be, 40 on the highway and 37 in the city. The hybrid flips those around. The city mileage is higher than the highway mileage because the more you use the electric motor, the more efficient the overall driving experience is. So driving at low speed, stop and go, city driving is where the hybrid is really excellent. Now the downside is from the lubrication standpoint, engine oil is designed to protect the engine and the various additives that are in it. It turns out they work best when the engine is fully warmed up, meaning the lubricant is somewhere around 130 degrees C or so. If you're not using the engine very much, and the way you warm up the lubricant is by running the engine, and the excess heat from combustion warms the lubricant. Well, if you're not running the engine, you're not warming up the lubricant, you're not activating those additives quite so much. So you have to be sure that you have the right mix of additives to protect against things like corrosion at low temperatures. A problem with internal combustion engines is some of the combustion product gets past the pistons and into the oil. And the two main products of when you combust hydrocarbons, probably not surprisingly, are carbon dioxide and water. And water in the oil is a bad thing. It can cause corrosion. It can bind with additives and cause them to drop out, do lots of bad stuff. If you're running a standard engine and you get it hot, like 130 degrees or so, you boil off that water, it goes away. If you're only starting the engine occasionally and not getting the oil hot, you can get significant water mixed into the oil and have problems, like I say, with corrosion, with foaming of the oil, loss of pressure in the hydraulic components that use the oil as a hydraulic fluid. So getting the water out, getting any fuel that gets in there out is an issue for the oil in a hybrid. Let's see, what other issues do we get?
It's it.
Oh,
It seems
well,
like what you're describing, Ed, is that
mhm.
hybrid vehicles really need a different kind of engine oil.
They need I wouldn't say different, but more advanced. Oh, and by the way, the obvious one, since your car has two motors instead of one, it costs more. So hybrids are more expensive than either a dedicated electric or a dedicated internal combustion engine.
So is that a showstopper for a lot of people? Because hybrids are quite popular.
Uh, if you look at the market share of hybrids versus EVs and internal combustion engines, it's the smallest by far. So I think that's part of it. Um, I will just tell you personally, I drive a hybrid, and it's what's called a plug-in hybrid. So I drive on the battery when I'm in town, and when I get home, I plug it into the wall and I recharge the battery. So it's possible for me, if I'm only going short distances, to not use any gasoline at all and have it be effectively an electric vehicle. But if we want to go out of state, if we want to drive 500 miles in a day, that means I couldn't do that in an EV without stopping for several hours. So we have a vehicle that we can drive and stop and refuel in the conventional manner at a gasoline station and keep going. So it's tremendously versatile in that sense. And it's up to the individual consumer whether the cost is worthwhile. In my case, I decided it was, but that's a personal judgment.
How much more expensive is it than
Well,
a pure EV?
that's hard to say. That probably the easiest thing to do would be to look at prices, and again, the prices change pretty regularly. Sometimes there are government incentives, and sometimes there aren't. Sometimes manufacturers will consider, like I say, in the United States, their corporate average fuel economy, and they'll discount these vehicles because you get a bonus, if you will, on your corporate average fuel economy for selling those vehicles. So their sales price may not reflect their true cost, and probably doesn't. But you're talking several $1,000s, I would say, in general. And you
And so
have to do the kill. Go ahead.
yeah, how long have you owned your hybrid?
Let's see. I've had it for 2 years now.
And
As I
so
say,
far,
it's a plug-in hybrid.
what's your experience been?
I don't even look at the price of gasoline anymore. I don't know what it is in my neighborhood, um, because our other vehicle is a dedicated electric vehicle. So we do most of our driving in the EV. We pretty much only take the hybrid if we're going out of state, which these days isn't that often. Uh, and I have to say our experience with both vehicles has been quite satisfactory. Now, we bought our EV when there was still a government incentive on it, so we got a substantial discount. We also have solar panels on the roof and a 10 kilowatt hour battery in the garage that charges with any excess electricity from the solar panels and runs our house at night. And we'll also charge the EVs. So if I'm charging the EV when the sun is shining, we're not even paying the going rate for electricity. And like I say, if I thought about it, I'm trying to remember the last time I put gas in the hybrid. It was probably February. Yeah,
This
I
year?
remember buying gas. Yeah, this year. I remember buying gas in February because I had to drive to Chicago and back.
And
That was the
do you
last
still
time
get
either of us bought gas. But anyway,
do you still get a full tank?
yes. Funny you should ask. The hybrid that I'm driving, and I'm not going to mention any brand names, but it gets 400 miles on a tank of gas. It has an 8-gallon tank. It averages 51 miles per gallon on the highway. And
Wow.
this is not a two-seater. It's a four-seat hatchback. So it's small. It would probably be considered a compact, but a it's not a tiny vehicle by any means.
So Ed, what was your favorite vehicle ever that you drove?
Oh my goodness. Well, working at General Motors, I got to drive Corvettes occasionally, and those were always fun to drive. Um, Enjoyed that a lot. Uh, Cadillac made something called an Elante for several years when I was working there, which was a two-seater convertible. Also fun to drive. I think the 0 to 60 time on that was about 3.9 seconds. Pretty fast. But I would not want to own either one of them, mainly because of the cost of upkeep on a luxury vehicle or a sports vehicle. It's funny, I worked for a car company for many years, but I don't really consider myself a car guy. I was not into cars before I joined General Motors. I couldn't tell you uh, what made a 57 Chevy, such a popular car. Uh, I know something about it, but I have always thought of cars more as a means of getting from point A to point B. Um, I really enjoy the electric car and other electric cars that I've driven. As I say, they're quiet. They accelerate very well from the start, even though they don't have a huge motor in them. Boy, favorite vehicle ever. That's a tough one. I don't like the big cars or pickup trucks or things like that. Um, Probably because I've lived in cities all my life and they're hard to maneuver around the city streets and the like. Wow, that's a tough one.
Pickups are very popular in the United States.
Yes, they are. Again, they became popular after the oil shocks of the 1970s and the first round of fuel economy standards, because at least then, the big push for the cars, the passenger cars, was to make them smaller, lighter, more efficient, put smaller engines in them. At the time that that was done, trucks were exempt from those regulations. So people who wanted a bigger vehicle were pretty much left turning to the pickup truck. And then
Mm.
pickup trucks evolved into these sport utility vehicles, which were often built on a truck chassis at the time. And for many, many years, decades, in fact, they were subject to a completely different tier of fuel economy standards. And since that has caught up now, I think the fuel economy standards are more unified, maybe not totally unified, but even those larger vehicles have standards applied to them. You're seeing families and the like still gravitating toward what they call an SUV or sport utility vehicle that is more truck-like. But I really think in the cities, the smaller vehicles are a lot more popular, as I say, for maneuverability, parking, getting in and out of structures, that sort of thing. They're much easier to get around with on the smaller streets.
Sure, but when you look at announcements from car companies today, and I think that this doesn't just apply to American car companies, right? Also
Mhm.
to Japanese car manufacturers, that SUVs are still very popular uh, for for reasons that it just carries more passengers, I guess.
I believe so. And Again, I don't know the numbers. I'm not an accountant, but it's my understanding that the larger vehicles have a higher profit margin for the manufacturer. So it makes perfect sense that they would market them more aggressively and want to sell more of them. And part of the way, and then if you're selling the bigger vehicles that get poorer fuel economy, you have to now sell more vehicles that get better fuel economy to bring your corporate average down. So as I say, that's why you start seeing the discounts. Discounts probably isn't the right word. You start seeing more favorable pricing on the EVs and the hybrids that they do make that maybe don't reflect the true cost of making that vehicle being passed all the way on to the consumer because the company has decided it's net positive for them for every big truck they sell to sell one of these EVs. And they
Yeah, I
factor
mean,
that in.
government policy really distorts market.
Couldn't put it
And
better myself.
well, it could be a positive thing as
Yes,
well. But thinking back at your career, Ed, what's your advice for the young people, people looking at, deciding on a career, going to college? Do you think lubrication and tribology is still a field that would be considered attractive for a young person today?
absolutely, absolutely. And it gets back to what tribology is. Now, if you're not familiar with the word, tribology comes from the Greek root tribos, which means to rub. So people will talk about friction wear, lubrication as branches of tribology, and there are various definitions, but I will tell you my favorite definition of tribology is one sentence. Tribology is the study of interacting surfaces. So wherever two things come together, it's tribology. And if you think about it that way, it's everywhere. Now, any place where two surfaces come together and move relative to one another. So that's not just cars and trucks. It's any form of transportation. It's any manufacturing process. It's pretty much anything you do around your house where you pick something up and move it. It's the shoes you wear and how they interact with the floor and different surfaces. Um, it has just tremendous application to, to all kinds of practical problems. And I find once you understand those principles, as you mentioned, I spent my career in automotive, but the principles I've learned are applicable to many other areas, particularly manufacturing, and not just cars, manufacturing of anything where you have all these moving bits of machinery and problems arise related to how you keep them running, how you keep them cool, how you keep them lubricated, how you prevent them from wearing out. Um, And I like to point out when we talk about friction, there's a general feeling when you talk about friction, the immediate reaction is friction is bad. Well, not necessarily. Sometimes friction is good. For example, mechanical brakes on I'll come back to the car. Your car stops by creating friction between the brake pad and the disc. And in that case, you want a lot of friction because you want to be able to stop a car quickly. In fact, anytime where you're trying to move energy between those two surfaces, you want a lot of friction. So, brakes, clutches, your hands on the steering wheel, or when you turn the knob on your radio. You want a lot of friction, but you also want low wear because you don't want those things slipping when you're doing that. One of the most interesting examples of tribology is any bolted joint. Anytime you screw or bolt two things together, when you tighten a bolt, what keeps the bolt tight? Friction. There's no glue or anything else in that uh, interface. So understanding the principles of tribology, friction in this case, is absolutely essential to understanding how fasteners work. Um, and I think there will always be a need for that. But even in the automotive industry, as I mentioned, I think there is going to be a demand for the internal combustion engine. Maybe it's being phased out in passenger cars, but I think long distance vehicles like trucks, um, and even longer distance vehicles like airplanes and boats, they're a lot harder to electrify efficiently. So I think you're still going to see internal combustion in very large sectors of industry and transportation. So there still is opportunity there. The decision as to how much, it's hard to say, but I think you'll still see a lot of research and active work in those areas and a lot of demand for lubricants. And I like to say the opposite. If a lubricant is a way of reducing friction between two surfaces, what is something that increases the friction between two surfaces? That's called an adhesive. And that's the same thing. It's managing the friction, the interaction between those two surfaces. So it's not just where you want the surfaces to move, it's where you want them not to move, is a tribological problem too. Uh, Glues, uh, tape, um, brazing, welding, all of these things essentially are tribological issues. So and can be analyzed with a lot of the same tools.
And we've always thought they were a different industry, didn't we?
Oh no, not
I mean, when we talk
not.
about adhesives, it's always like, oh, it's a different industry, but it's not, is what you're saying.
It's the very same principles. It's the same chemistry. It's the same interaction of the surfaces, except here, instead of trying to reduce the force between them, you're trying to increase it. And it makes sense that if you do one thing to reduce it, maybe doing the opposite is how you increase it. So you'll find that. The other thing I mentioned, as you mentioned in the introduction, my background, my undergraduate degrees are in material science. Now, my PhD is in mechanical engineering, but that is just an artifact of the fact that my advisor for my PhD was in the mechanical engineering department at the University of Michigan. Tribology does not fall nicely into any of the predefined engineering disciplines. You'll find that in lubricants, for example, when we talk about additives and how they interact, we're talking chemistry. If we're talking about the viscosity of the fluid and how it reacts as it moves through passages like through bearings or um, channels within the engine, you're talking mechanical engineering, fluid mechanics, and fluid dynamics. When you're looking at what actually happens when the surfaces rub together and you start to move material around, now you're into strength and yield strengths and fatigue and other things that are properly the area of material science. How you actually remove material from a surface is more material science. So what I like to say is the tribologist has to be at least generally familiar with all of those things. And it helps if he or she specializes in one of them. And what I particularly find is a lot of the people who identify as tribologists have the chemistry background. Quite a few of them have the mechanical engineering background. I think the fewest of them that I know have the material science understanding. But that what we say as a tribologist has to be a jack of many trades and a master of at least one. So it is a lot of opportunity there if you find your if you want to be challenged and get a broader background. Tribology is a great field where you can study all of those things. And of course, I've taken mechanical engineering and chemistry courses, advanced courses in many cases along the way. But the real heart of my understanding and where I think I offer something special is the material science area.
Yeah, and I think you have to start with the material. One of the things I was going to comment when you were talking about um, um, GM um,
Mhm.
is the changes in materials, right? I mean,
Oh, yes.
it it's tremendous. I mean, I think you're not only talking about aluminum, you're also talking about composites, um,
Yes.
and it's a different conversation altogether. But it definitely the material that you're using has a lot to do with how you lubricate them. So
Yes, it
it's
does.
all one. It's all one system.
Well, I like to say if you're I saw an analysis of if you will, an average passenger car, and what elements, if you look at the periodic table of elements, what elements are most present in a passenger car? Probably not surprising. Iron is the most common. We still use steel and cast iron for the big, heavy load-bearing components. But second after that is aluminum because we replaced a lot of those components, not just the engine, but a lot of the bracketry supports, a lot of the chassis components, uh, the structure that holds the suspension together. Where we can, we've moved that into aluminum. But what would you think is the third most common
Plastic.
element in a vehicle?
It,
Well, if you think of it, that's carbon and hydrogen, which are relatively light. So not by weight, not so much maybe by volume, but by weight, the third most common element in today's passenger car is copper. It's all
okay.
those wires, all those electrical components. There's a tremendous amount of copper in a modern vehicle. In fact, they are not so much transportation anymore as they are rolling infotainment systems. Um, we used to talk in the 1980s about the fact that a car in 1985, your average passenger car had more computing power than the Apollo spacecraft did. Well, nowadays, the average key fob for your car has more computing power than an Apollo spacecraft did. So
Wow.
just the explosion of electronic components and capabilities, and not just infotainment, but also safety features, backup cameras, for example, all the cameras, the different sensors that go with adaptive cruise control. These are just, it's just, to me, amazing how far we've come along. And that, again, as I mentioned before, is what's making the self-driving car, I honestly think, possible well within our lifetimes. We will see fully self-driving vehicles out there. And some folks of a certain
Definitely.
age, some folks of a certain age find that uncomfortable. Um, they don't want to give up the control of the vehicle. Well, think about the things, even in today's vehicle, that you used to have to do to drive. If we go back to 1900, I mean, just starting the car involved manually adjusting the choke, manually adjusting the timing. It was getting out of the car and pulling on a crank at the front of the car. Um, I don't hear anybody complaining about not having to do those things anymore. So I really think it's a matter of the generation and what you're used to. Um,
Yeah, yeah,
you,
and I
you know,
think
you
in
can,
Japan, they're working on a lot of these things because they have an aging population.
I think so.
So,
And at what point do we have to say that people of whose reflexes might not be as quick or have other uh, things that make it difficult for them to drive. Their eyesight may be failing, that sort of thing. Who says these people don't deserve mobility too? I think they do. Um, and particularly the issue for some drivers, they don't realize when they're losing those capabilities. And we still have a horrendous amount of incidents on the road from people who probably were fine drivers once, but aren't anymore. How do we manage that? Well, the cars their sensors don't lose their efficiency as they get older. They don't get fatigued. They're able to look forward, backward, and to the side simultaneously and process all that information. There's every reason to believe, and some people are already making the case, that these cars are better drivers than the average human now. And I think that's probably
autopi-
true. You know?
well, for the most part, that's how planes are flown, right? Autopilot.
Yes, fly by wire, they call it. Um, well, that's part of it. And the fact that the controls, there's no longer any mechanical connection between the yoke that the captain pulls on and anything that controls the engines. It's all a computer senses how that control is moving and sends an electric signal to the appropriate controller unit to modify the thrust and the angle of the flaps and all of those other things. So really, it's the computer doing the flying now, but relying on inputs from the people.
Yeah. The question is, how
But
many
I,
pilots do you need? Do you need in the cockpit, one or two, right? So, but
well,
yeah. Anyway, Ed, it's always
mhm,
interesting talking to you. Always.
okay,
Thank you so much for your
yes.
time, and
Well, this was fun.
yeah, and good luck with what you're doing, and I'm sure you have a lot more ideas to share with us in the future.
Yes, this was fun. I look forward to seeing you at the next meeting where we both happen to be. And I really can't stress enough how important I still think these face-to-face conferences are, like Fuels and Lubes Asia. I can't tell you how many of the projects I've ended up working on had their start after somebody gave a talk and I was in the room, not looking on Zoom. I was able to go up to the speaker afterwards and say, thinking about what you said, have you thought about this? And we've actually ended up working together and becoming colleagues. I I really think that's invaluable, and I appreciate all that you do in that respect. So
I
thank you.
agree with I agree with you, Ed. Thank you so much. Thank you for your time and your input and your contribution to the industry.
Thank you.
Have a great day. Bye bye.
Bye.